Something arrived at Cerro Pachon before anyone knew it was coming. 10 days before the world officially discovered it. 10 days of silent footage sitting untouched in a database of an object that had no business being there. Nobody was watching for it. Nobody knew to look. And when scientists finally went back through the archive, months later, they found it staring back at them. A visitor from outside our solar system. Already photographed, already tracked, already inside the frame, while humanity was still catching up to what had just happened above its head. This is not a story about a telescope. This is a story about what we almost missed. For decades, the night sky was treated as something fixed, something you could photograph once and trust. That assumption just died on a mountaintop in Chile, and almost nobody outside the astronomy community understands what that actually means yet. Here is where it starts. On the summit of Cerro Pachon, 2,682 meters above sea level, in one of the driest and darkest patches of atmosphere on Earth, sits a machine built over more than 2 decades, at a cost that eventually reached roughly $800 million, funded jointly by the U.S. National Science Foundation and the Department of Energy. It carries the largest digital camera ever constructed, a 3,200 megapixel sensor mounted on an 8.4 meter telescope, engineered specifically to do something no observatory before it has ever done at this scale. Watch the sky change in real time every single night for 10 straight years. Officially, it is called the Vera C. Rubin Observatory, named after the astronomer whose work first gave humanity hard evidence that something invisible, something we still cannot directly detect, makes up most of the mass in the universe. Read that again. The observatory is named after a woman who proved that most of what holds galaxies together is something we cannot see, cannot touch, and still cannot explain. That is the DNA of this entire project. It was built to hunt the invisible, but here's where it gets uncomfortable. This telescope isn't just capturing pretty pictures of nebulae for press conferences. It is running what its own team calls, without irony, the greatest cosmic movie ever made. Every 40 seconds, it captures a new detailed image of the sky, not once a night, not once an hour, every 40 seconds. Each night, it gathers around 10 terabytes of raw data and generates as many as 7 million individual alerts. Automatic flags triggered the instant something in the sky moves, brightens, dims, or changes in any measurable way. Think about what that number actually means. 7 million alerts. In a single night. That is not a telescope. That is a surveillance system for the entire visible universe, and it just went live. And this is where everything changes. Because a system built to notice everything that moves does not just find comets and asteroids. It finds the things nobody was expecting to find. It finds the things that shouldn't have been there. Let's go back to the beginning, because the sequence of events here is the part almost nobody is talking about correctly. In the first 10 hours of test observations, not even the real mission, just a preview, the observatory had already logged millions of galaxies, millions of Milky Way stars, and thousands of asteroids. In just over 10 hours of test observations, Rubin Observatory had already captured millions of galaxies and Milky Way stars and thousands of asteroids. That was the appetizer. Those 10 million galaxies represented roughly 0.05% of the nearly 20 billion galaxies the observatory is expected to document over its full 10-year survey. Sit with that fraction for a second. A 20th of 1%, and it was already enough data to overwhelm most existing archives on Earth. In fact, the amount of data this single facility gathers in its first year alone is expected to exceed everything ever collected by every other optical observatory on the planet combined. That was before the real mission even started. On June 30th of this year, 2026, the observatory crossed the threshold from testing into full operation. The historic effort, called the Legacy Survey of Space and Time, officially began, with the camera capturing the entire visible sky roughly every 3 to 4 nights for the next decade. The head of the survey program, Jelko Ivazic, explained that the decision to move forward came only after a long stretch of system optimization and a careful technical review. Image quality, survey speed, uptime, calibration accuracy, all of it had to be verified before they let the machine loose on the real thing. In other words, this wasn't rushed. This was deliberate, which makes what happens next even more unsettling. Because before the official mission had even begun, while the telescope was still in its commissioning phase, still being calibrated, still not fully trusted to run its own detection pipeline, it had already, without anyone noticing, photographed something that should not exist inside our solar system at all. Here is where the story turns from impressive to strange. In the summer of 2025, a network of automated telescopes called ATLAS, designed specifically to hunt for objects that could threaten Earth, spotted something moving fast, extremely fast, from beyond the orbit of Jupiter. On July 1st, astronomers announced they had spotted a mysterious object traveling toward the inner solar system at more than 130,000 miles per hour. That is not solar system velocity. Objects that belong here, bound by our sun's gravity, do not move like that. The Minor Planet Center confirmed it days later. This was the third interstellar object ever recorded in human history, an object whose trajectory was so extreme, so hyperbolic, that it could not have originated anywhere within our own solar system. They named it 3I Atlas. But here's the part that should genuinely unsettle you. Rubin Observatory had already seen it before Atlas ever announced anything, before the object had a name, before anyone on Earth knew it existed. Months later, a research team went back through the Rubin Observatory's early commissioning data, the test footage, the throwaway calibration images nobody thought would matter, and they found it. The observatory had serendipitously photographed 3I Atlas 9 separate times between June 21st and July 2nd, completely by accident before the object was officially discovered, and captured it several more times in the weeks that followed. Nobody was looking for it. Nobody knew to look. The machine simply recorded it, filed it away, and moved on, because at that point its systems weren't even built yet to flag rapidly moving solar system objects. Analyzing those images required scientists to build entirely custom techniques after the fact, since the observatory's pipeline for tracking fast-moving objects wasn't operational yet at the time the images were taken. Think about what that means for a second. A 10-day head start, sitting quietly in a hard drive, on the third confirmed visitor from another star system in the history of human astronomy. In fact, the discovery was close enough that researchers half-joked the object was almost named 3I Rubin instead of 3I Atlas, because the telescope had unknowingly beaten the official discovery by more than a week. And this is where the real story, the one most coverage completely undersells, begins to unfold. Because 3I Atlas did not behave the way anyone expected. Early observations showed its coma, the glowing shroud of gas and dust released as a comet heats near the sun, physically growing, expanding from roughly 13,000 kilometers across on June 21st to nearly 19,000 kilometers just 11 days later. Something was already happening to it, long before it should have been active at all, this far from the sun. Spectroscopic analysis found the coma had a distinct reddish tint composed largely of unusually large dust grains, likely colored by irradiated organic compounds. Organic compounds on an object that formed around a star that may not even exist anymore. Here's where it gets worse. Researchers estimate 3I Atlas could be nearly 12 billion years old, so ancient that the star system it came from may have already died before it ever finished its multi-billion-year journey toward us. Read that again. This object may be a ghost, a physical remnant, still traveling, from a star system that no longer has a star. It has been drifting through the emptiness between stars for longer than most solar systems have existed, and the first place it happened to be caught on camera was a mountaintop in Chile, by a telescope that wasn't even trying to look for it. Naturally, the speculation exploded. A prominent Harvard astrophysicist publicly floated the idea that this object wasn't a comet at all, that its trajectory, its speed, its behavior were consistent with something engineered. Shortly after its discovery, Harvard astronomer Avi Loeb and colleagues proposed that 3I Atlas could be an alien spacecraft. And once that idea was on the table, the scientific community did something most people don't expect. They took it seriously enough to test it directly. The SETI Institute pointed the Allen telescope array at the object for more than 7 hours, scanning across a wide band of the radio spectrum, hunting for the one signature that would separate a rock from a machine, a narrowband radio signal, the kind that does not occur naturally. During the search, researchers detected nearly 74 million narrowband signals, the overwhelming majority of which were quickly traced back to human interference. After stripping away every signal that could be explained by Earth-based technology or satellites, they were left with essentially nothing. Every remaining candidate signal was ultimately traced back to sources on Earth or in Earth orbit. None of it came from the object itself. A separate team using the Green Bank telescope ran the same test from a different distance and frequency range and reached the same conclusion. That team found 9 borderline signals worth a closer look, and every single one of them was ultimately traced back to known transmitters here on Earth. So, no alien technology, no hidden transmission, no confirmation of the nightmare scenario. As one of the researchers involved put it afterward, past work has already shown that 3I Atlas looks like a comet and behaves like a comet, and this new data confirmed it is not emitting anything resembling a technological signal. In the end, there were no surprises. But here's where most coverage stops, and where it shouldn't. Because the absence of a detected signal is not the same as an explained mystery. The very researchers who ran these searches admitted there is currently no evidence that interstellar objects are anything other than natural, but given how few of them we've ever recorded, and how plausible it is that an interstellar probe could exist among them, thorough study remains warranted. In plain language, they didn't find a signal this time. That doesn't mean the question is closed. It means we don't yet have the tools or the luck to answer it with certainty. And Rubin Observatory is about to change how many chances we get to try. This was only the third interstellar object ever confirmed. following 1I Oumuamua in 2017 and 2I Borisov in 2019. 3 objects discovered across nearly a decade, almost entirely by accident, using instruments that were never designed for this specific job. Now imagine a machine built from the ground up to do nothing but notice things like this every single night for 10 uninterrupted years. Researchers studying Rubin's future capacity estimate the observatory could detect somewhere between 3 and 7 interstellar objects reachable by a proposed rapid response spacecraft mission out of the wider population it's expected to find. Some estimates suggest the observatory could eventually catalog thousands of solar system objects that have simply never been seen before. Not just interstellar visitors, but comets, asteroids, and unexplained transient events buried in a part of the sky. Nobody has ever watched this closely, this often, for this long. And this is where the scale of what's coming should actually make you uneasy, in the way genuine uncertainty is supposed to make you feel, not through fabricated horror, but through the plain mathematics of probability. In images captured just to optimize the new system, not even real science observations, the observatory had already detected 11,000 new asteroids and logged dozens of previously unknown objects in our own solar system. In a matter of days, 11,000 new asteroids, found by accident during equipment calibration, not during the actual 10-year survey, during the warm-up. Now think about what new actually means in that sentence. It does not mean newly created, it means newly seen. Those 11,000 objects were already there, silently orbiting the sun, completely undetected by every telescope humanity has ever built, until this one machine happened to glance in the right direction while checking its own settings. What else is out there that we simply haven't looked at correctly yet? This is the uncomfortable core of the entire project, and it's the part that gets buried under headlines about pretty nebula photos. One of the most anticipated outcomes of this observatory isn't cataloging what we already know exists. It's the likely discovery of entirely new categories of objects that we don't even have a name for yet. Not a new asteroid, not a new comet, a new type of thing. Something that has never been classified because no instrument before this one has ever been sensitive enough, fast enough, or persistent enough to catch it. And the scientists involved are not being subtle about the stakes. In their own words, this project is bringing the universe to life, illuminating pulsating stars, supernova explosions, the fossil record of entire galaxies, clues to the mysteries of dark energy and dark matter and phenomena we have never seen before, full stop. Let's slow down on that phrase, dark energy and dark matter, because it connects directly back to the woman this entire facility is named after, and it is the true, quiet, terrifying core of this whole endeavor. Dark matter and dark energy together make up roughly 95% of everything in the universe, and despite that overwhelming majority, their fundamental properties remain completely unknown to science. Read that again, 95%. We do not know what most of the universe is made of. We can measure its gravitational fingerprints. We can see galaxies moving in ways that shouldn't be possible without something invisible pulling on them. We can watch the universe's expansion accelerating for reasons nobody can fully explain. But the substance itself, the actual nature of dark matter, the actual mechanism behind dark energy, remains one of the largest unresolved questions in the history of human knowledge. And this observatory, right now, tonight, is quietly gathering the largest single body of evidence ever assembled to try to crack it open. This is not chaos. This is strategy. A 10-year, deliberately engineered campaign to photograph the entire visible sky over and over and over again, specifically so that scientists can compare each night against the last and catch the tiny, almost invisible shifts that reveal how galaxies are actually moving, how mass is actually distributed, and whether our current model of the universe is even close to correct. But here's where the story escalates again, because dark matter isn't the only invisible thing this telescope has been quietly built to hunt. The observatory is also expected to help answer one of the most stubborn open questions in our own cosmic backyard: whether a hidden 9th planet is really out there, lurking in the far outer reaches of our solar system, its existence inferred only from the strange, clustered orbits of a handful of distant, icy bodies. Planet 9 has never been directly observed. Its existence is only theoretical, built entirely from gravitational anomalies in the outer solar system that some scientists believe can only be explained by a massive, unseen object. If it's really there, an instrument built specifically to catch faint, slow-moving objects across the entire southern sky, every few nights, for a decade, is arguably humanity's best ever chance of finally seeing it directly. Which means somewhere in the next 10 years, one of two things is likely to happen. Either this observatory finally photographs the 9th planet of our own solar system for the first time in human history, or it rules out its existence entirely, forcing scientists to explain those strange outer solar system orbits some other way. Either outcome rewrites textbooks, and still, this is only one thread of what's unfolding. Because while astronomers were tracking 3I Atlas through the inner solar system, other missions were quietly repositioning to take advantage of its passage. a level of interagency coordination that most people never hear about. NASA's Juno spacecraft, still orbiting Jupiter, was positioned to potentially observe the object during a close flyby in March of 2026, even though Juno's limited remaining fuel made a full mission redirect unlikely. Separately, astrophysicist calculations placed NASA's Psyche spacecraft passing within roughly 45 million kilometers of the comet in September 2025, while the European Space Agency's JUICE spacecraft passed within about 64 million kilometers in November of that same year. Despite the difficulty of retasking a spacecraft mid-mission, JUICE did manage to observe 3I Atlas that November, using its cameras, spectrometers, and particle sensors. Multiple spacecraft, built for entirely different missions, quietly turned their instruments toward a single interstellar object as it passed through, on the off chance they could learn something no one else could. At one especially delicate moment, the comet's ion tail was predicted to sweep directly across the path of NASA's Europa Clipper spacecraft in late October and early November of 2025, giving scientists a rare chance to detect direct physical evidence of an interstellar comet's tail using instruments never designed for that purpose. This is what most coverage misses entirely. This wasn't one telescope quietly doing its job in the mountains of Chile. This became, briefly, a coordinated multi-agency, multi-spacecraft effort, an international scramble to extract every possible data point from an object that will likely never pass through our solar system again. Because 3II Atlas is not slowing down, and it is not staying. Its orbit is extremely hyperbolic, a one-way trajectory that confirms it did not form here, was never bound here, and is now leaving permanently back into the emptiness between the stars. It came from nowhere we can identify. It stayed for months. It sparked genuine, serious, scientific speculation about artificial origin. And now it is gone, forever, having given up only a fraction of its secrets before vanishing back into interstellar space. So where does that leave us? It leaves us with a telescope that just started its real mission 4 days ago, as of this writing, having already proven, before it was even supposed to be capable of doing so, that it can catch something interstellar, something ancient, something that arrived from beyond our solar system, completely by accident, while it was still being calibrated. The observatory's public gallery is already live, letting anyone explore the first images captured from this new era of astronomy. But the real story isn't in the gallery. The real story is in what hasn't been found yet, in the 7 million nightly alerts that scientists are only beginning to learn how to sort through. In the thousands of asteroids discovered during a system check, nobody expected to produce actual science. In the fact that a machine designed to answer the biggest question about the invisible universe, what is dark matter, what is dark energy, is also, simultaneously, becoming humanity's best chance at ever directly detecting a visitor from another star system before it slips past us again. Scientists involved in this search have said it plainly. Future surveys are likely to amass such a large population of interstellar objects that researchers will finally be able to tell which ones are ordinary and which ones are genuinely anomalous. Right now, we have 3 data points, 3 objects spread across 9 years, mostly caught by accident. Soon, we may have dozens. And somewhere in that growing catalog, if the last 3 objects are any indication, there's a very real chance that something will show up that doesn't fit the pattern, something that moves wrong, something that brightens wrong, something that, this time, doesn't get explained away after 7 hours of radio silence. Nobody knows what that object will look like yet. Nobody knows when it will arrive, or whether Rubin Observatory will catch it in real time, or whether, like 3I Atlas, it will simply sit quietly in an archive for months before anyone realizes what they're actually looking at. What we do know is this. For the first time in human history, we have built a machine capable of watching the entire visible sky closely enough and often enough that nothing can pass through unnoticed for long. The question is no longer whether something unexpected is out there. The last few years have already answered that question. The question now is simply this. When the next one arrives, will we be ready to understand what we're seeing before it disappears again, back into the dark, taking its answers with it?